Unit 1, Solving Inequalities. Compound inequalities are inequalities joined by the words and or. The solution to an or inequality is any value that makes either inequality true. The solution to an and inequality is any value that makes both inequalities true. So here we have 3x plus 9 is less than negative 3, or 2x plus 1 is less than 5. I'm going to solve the inequality on the left first by adding or subtracting 9 and then dividing by 3. So I get x is less than negative 4. Then I'm going to solve the inequality on the right by subtracting 1 and then dividing by negative 2. Be careful whenever you divide by a negative number, you need to switch the inequality symbols. So we started off with a less than. Divide by a negative is going to switch the inequality sign to greater than. Now I need to check both of my inequalities. And since it's an or, I'm going to check different numbers in each inequality. So the first one, I need a number less than negative 4. I'm going to choose negative 5. And I'm going to plug it in to this inequality. When I do, I get negative 6 is less than negative 3, which is true. Then I need to check my second inequality. I need a number larger than negative 2. I'm going to choose negative 1. Check it in the original equation, the original inequality, and I get 3 is less than 5. Both of those are true. The way we represent this on a number line is we want anything to the left of negative 4 and anything to the right of negative 2, and we want these symbols or these circles to be open because of the less than symbols we started with. The way we write our answer is x is less than negative 4 or x is greater than 2. Two x minus 1 is less than or equal to 3x, and x is greater than 4x minus 9. We're going to start this one off in a very similar fashion by solving both of the inequalities. So now I need a number that is greater than negative 1 and less than 3. Since this is an and, I need to check one number in both equations. So a number bigger than negative 1 and less than 3, I choose 0. Check it in the first inequality, I get negative 1 is less than or equal to 0. Check it in the second one, I get 0 is greater than negative 9. Represent this on a number line. I have negative 1. I want numbers bigger than negative 1, but smaller than 3. The reason why negative 1 is a closed circle is because it's equal to, and then the 3 is an open circle because it's just less than. The way we write our final answer, negative 1 is less than or equal to x, which is less than 3. For ands, you're going to shade in between two numbers. This one is also another way of writing an and inequality. First thing we're going to do is we're going to add 3 to the left side of the inequality, the right side, and the middle. And then we're going to divide all 3 sections by 2 until x is all by itself in the middle. So now we have negative 1 is less than or equal to x, which is less than or equal to 9. I'm going to check a number between negative 1 and positive 9 in the original inequality. So again, we plug it in to the one we start with. I chose 3, and then we get negative 5 is less than 3, which is less than 15. This one's an and, so we shade in between the numbers, and both of these are closed circles because we have less than or equal to symbols. Solving absolute value inequalities is a little bit more complicated. So we have 2x minus 3, absolute value, is greater than 7. So the first step is to set up two equations to find the critical points. Two x minus 3 equals 7 and 2x minus 3 equals negative 7. These are going to give us our boundaries for our inequalities. That's why they're called critical points. So then solve both of these. We get x equals 5 and x equals negative 2. The next step is to place the critical numbers on the number line. So I have two open circles. One is at negative 2, one is at positive 5. And then the next thing I need to do is test the three different intervals of the number line. So our number line is broken up into three sections. We have to the left of negative 2, we have in between negative 2 and 5, and to the right of 5. So I'm going to choose a number from each of these sections, plug it into my original inequality, and see where it works. First, I'm going to check x equals negative 7. I plugged it in, and I got the absolute value of negative 17 is greater than 7. From the middle section, I chose x equals 1. Plugged it in, and I got 1 is greater than 7. And then from the last section, I have x equals 8. Plugged it in, we have 13 is greater than 7. So I'm going to shade in any number on a line where the values are true. So 17 is greater than 7. That's true. Negative 1 is not greater than 7. And 13 is greater than 7. So again, shading in the line all the values that are true. What that means is I need to shade both the outside regions. I leave the inside alone because those values are not going to make the inequality true. The final step is to write the compound inequality that describes the number line. Since I shaded on the outsides, this is an OR. I want numbers less than negative 2 or greater than 5. Let's try one more. So here we have negative 2, absolute value x plus 1 plus 5 is greater than or equal to negative 3. Set up two equations to find our critical points. This one's a little bit more involved. First I have to get rid of the 5, then I have to get rid of the negative 2. So I have the absolute value of x plus 1 is equal to 4. My two equations, x plus 1 equals 4, x plus 1 equals negative 4. My critical points are x equals 3 and x equals negative 5. Step number 2, place the critical numbers on the number line. Negative 5, positive 3. These ones I shaded in because I have a greater than or equal to symbol. I'm going to test the three intervals on the number line. Outside, inside, and outside. First one I chose is x equals negative 6. You can choose any number to the left. It doesn't matter. Negative 6, negative 7, negative 10. Shouldn't matter. Your results will be the same. After I plugged in the first one, I got negative 5 is greater than or equal to negative 3. Choosing a number in the middle, I'm choosing x equals 0. Plugged it in, I got positive 3 is greater than or equal to negative 3. And then from the last section, I have x is equal to 5. And I get negative 7 is greater than or equal to negative 3. Negative 5 is not greater than or equal to negative 3. The inside is true. 3 is greater than negative 3. And the right side is also not true. So the only place I'm going to shade here is in the middle. Since I shaded in the middle, this is an AND inequality, and I want the x values that are in between negative 5 and positive 3.